Okay, now we'll see how to use Tracker. You can just Google it and download the program. This is the program on the internet, and it's 4.92 at the moment. You can download it clicking on this. There is a note here, warning, saying that this bit here, saying that you need QuickTime 7.74, not 7.76. It doesn't work well with that, so you might have to uninstall QuickTime, the later version of QuickTime, and put the older version of QuickTime on. And you need also Java 1.6 or higher. Okay, so assuming you've downloaded and run it, you just have to open it and import your video. So just go open and find the video. I've got one here. It's .mov, which is a QuickTime movie. And we want to analyze when the ball hits and rebounds. So we could actually reduce the video length to the bit of the collision. So I'm just pressing the play button here, and the ball comes in very soon. There it is there. So we could actually go start the frame slider there, and we can stop it there. So put set end frame, and so only looking at that short bit there. Now first of all we need to put in the ruler. To do that, you just put a new calibration stick, and this is the stick here. Now you need to measure it with something in the background. For example, if you know how long that piece of tape is, you could line that up with the piece of tape, and you type into here the length of that tape. So if it was 20 centimeters, if you put in 20, then all your results will be, your speeds will be in centimeters per second, distances are in centimeters, because you've put this in centimeters. Okay, now what we need to do is click on all the points. So we just take that back to the start, and to track the points you just go on to track new point mass and then hold the shift key down and click on the middle of the ball, and it'll record all the data. Now we're only going to do one ball at a time. Now this is quite rough. You can, when you do yours, you make sure you're exactly in the center of the ball. I'm just doing this as an example. Now at the moment the ball is coming into the collision, so what we are going to be working out with this is the initial velocity of object 1. We could call it U1. And then after the collision, this is the final velocity of object 1, so we'd call that V1. And having finished this, we would then go and repeat it for object 2, the ball on the bottom. Now when that's finished, we can select many different variables. Over here on the graph at the moment it's plotting X. We could actually plot Y. You can easily see that the Y coordinate changes at this point here. To work out what that point is, we can find out the location of that point, and if we scroll down in the table, you can see it's occurring when time is 0.179. So 0.179 seconds, that's when basically the interaction is occurring. So we want to get the velocity before that and the velocity after that. Now to get the velocity before and after, we need to change this to give us the velocity values. We don't want to have it in x and y coordinates and work separately like in projectile motion. We'll just do it as vectors, so we'll just get the velocity as a combined x and y, and that's still highlighted on our 0.179. so we want to actually split our data up and work out the average velocity before and average velocity after. So to split our data, we're going to copy all this into Excel. Just make sure that we're copying the right columns. So we want time as the default. Instead of R, we don't want R. R is the distance from the origin of the axis, which is we're not interested in that. We want the velocity values, so we check the velocity box, and we want the angle of the velocity. So velocity and angle. That's displayed in the table. So now we'd have to do is copy all of that data there. So highlight all of that, and we can right click, copy selected cells, and then open Excel and paste it in, Control V, and it was 0.179, which is this one down here, which is where the interaction was occurring. So we could delete those three there, and we've split it into data before the collision and data after the collision. Alright, so now we want to get the average velocity before. So ignoring the first and the last, because the velocities are at the start and the end use points either side of it, we can just grab a set in between. Doesn't really matter how many. So we want to use that data set. We're going to go somewhere like this, equals average. Now it says select the data set, so we'll just do that again. Select the velocity column, set of velocities there, and close the bracket and enter. So on average it's 2.49 times 10 to the power of 2, in other words 249. So 249 centimeters a second is the incoming velocity u1. If we want the outgoing velocity of v1, then we'd average this column down here. Likewise, if we want the angle, we're going to average that angle there, and that's the angle it's coming in at. So looking back here, the theta v is reference to the direction it's heading in. So if it's heading in this direction, the angle is the angle with respect to the tail. So if you drew in an axis here, the angle is the angle that it makes from the positive x axis at the tail. So you can see it actually quotes the angles to start off with. Let's go have a look at some of these angles over here. You can see it starts off with negative values, minus 135. Minus 135 is actually the angle from here all the way around to there, and because going clockwise is negative, and you can see it's roughly staying a constant angle, which it is going through there. So having got the velocity and the angles, then we can go and do the momentums, draw momentum diagrams like we did from the Essentials book.